So here we go. Yeah, thank you very much for the introduction. Thank you very much for the invitation to be here and for the possibility to share some results from about 3 years of work from one of my main areas of research. And as you can see, this is not all work by myself alone, which I'm presenting. There's also a lot of input by colleagues from a few different institutions that went into this presentation today. So as you already heard, very simply put, I am interested in what's close to me. So I have so far restricted myself mainly to the Quaternary, and I have a strong regional focus with my work. And growing up in Munich, that's maybe a bit of an optimistic photo, and in Bern, growing up as a geologist at least, the regional Quaternary, that was for me for a very long time synonymous with the glaciations of the Alps. So in both these sites, we are located full on in the Alpine foreland, as you see in the background. And on the right here, you see a map of the ice extent of the last glacial maximum in the European Alps. See, Munich is just outside of the LGM ice extent, and Bern was covered by a few hundred meters of glacier ice. So that's what I got drawn to very early on. And the sedimentary and the geomorphological record or the imprint that these past glaciations leave on the Alpine foreland has been summarized quite some time ago, more than 100 years ago, by Penck and Brückner. And what they described by this glacial imprint is on the exterior of the former ice margin, a vast outwash plain with braided meltwater rivers. And the remnants of these old glaciations are today encountered in the Alpine foreland in the shape of gravel terraces, which are relatively isolated deposits at different elevations, which probably mark near peak glacial conditions at different stages during the Quaternary at different periods of glaciation. Here is an example what these gravel terraces look like in practice. That's a picture of my favorite gravel pit. I think everyone should have a favorite gravel pit. Very beautiful deposit. If we move further to the interior, below the former ice extent, we encounter something that's also very close to me. That's these glacial basins, previously often referred to as the tongue basins. We prefer to speak of overdeepenings, which are closed basins eroded under the ice that, as soon as the ice starts to retreat, begin to fill up with sediment. I could talk for quite some time about these as well. We are currently part of a big ICDP project drilling into some of these overdeepened basins around the Alps. And if you're interested, feel free to have a look on our website. What we are increasingly seeing is that in a lot of cases, not only the gravel terraces, but also the overdeepening fills probably reflect only a quite short amount of time. So we are in a situation that the deposition during the Quaternary in the Alpine foreland is quite discontinuous, and where we have sedimentary archives, these are often rather short-lived. So in order to get a better view of the entire Quaternary, I started to look a little further. So the question for me was, where does all this sediment go if it does not stay in the Alpine foreland? And we actually don't have to look too far for that. If we go beyond the Lake Constance, beyond Bodensee, which is one of these overdeepened basins, in the example of the Rhine system, we encounter the Hochrhein, the High Rhine area, which is a narrow river valley. There's not much space for storage of sediments. But if we move even a little further, then we encounter this pretty wide corridor of lowlands along the Upper Rhine stretch. And that is where we'll spend the rest of the time for this presentation. So if we zoom in a little closer, this is a digital elevation model of this area. And here's what it looks like in practice if you're out there. So this is the view from Schauinsland, just outside of Freiburg, which is one of the westernmost peaks of the Black Forest. And what we're overlooking here is a pretty much spectacularly flat plain, except for the Kaiserstuhl volcano that is here in the center. There is not much topography to see. And that is our target of work. What we're overlooking there, that is actually the Upper Rhine Graben. The Upper Rhine Graben is part of the so-called European Cenozoic rift system, which is a series of extensional basins that have formed in Central Europe in response or as a result of the alpine orogeny. So to put it very simply, the African plate and the European plate started to collide in Eocene times for our purposes. And by the indentation of the African plate into the European plate was torn open perpendicular to this collision zone. And one of the places where it tore open is the Upper Rhine Graben. So what we're observing there since roughly the Paleogene is extension of the crust. Where we observe extension, we observe subsidence. Where subsidence occurs, we create accommodation space. And where accommodation space is available, we have potential to accumulate large amounts of sediments. And as we see from all kinds of instrumental data, the Upper Rhine Graben is still in a bit of a different shape, tectonically active until today. And it has a length of a little more than 300 kilometers. Depending where you look at it, it's 30 to 50 kilometers wide. And in the center, it has subsided by few thousands of meters since the Paleogene. So we are really talking about a large-scale sediment sink. And in our case of the Rhine system, we are talking about the first large-scale sediment sink downstream of the Alps. So that's where we have a really good potential to look for a long-lasting and major sedimentary archive of the alpine glaciations, but not only of those. So of course, in here we also accumulate material derived from the Graben shoulders, from the lower mountain ranges there, like the Black Forest that we've seen before, but also from tributaries that deliver sediment from the hinterland. And this sedimentary archive is quite spectacular. So from all kinds of exploration that has been done for decades now, we know at first order quite well what the depth distribution of the Upper Rhine Graben roughly looks like. So here you see a map of the unconsolidated sediment fill of the Upper Rhine Graben, so the Pliocene to Holocene or to present day sediment infill, which in a lot of places is about 200 to 300 meters thick, but towards the north reaches values close to 1,000 meters. That looks quite simple here. it's unfortunately not exactly as simple. So due to this extension and breakup of the crust underneath the Upper Rhine Graben, what we're actually looking at are a lot of individual blocks separated by faults, which subside possibly at different times, but definitely at different rates. So the picture is, on a smaller scale, quite complicated. And that is very nicely illustrated by this image here. So this is a block showing a 10 by 10 square kilometer section of the Mesozoic cover underneath the city area of Freiburg. And you see within this distance of a few kilometers, we observe offsets of few hundred meters along individual faults in differential subsidence. So the continuity of sedimentation and correlation can again be somewhat tricky. So as I've mentioned before, the Upper Rhine Graben has been explored quite a bit, especially by the geological surveys from the surrounding states, and mainly with a focus on all kinds of applied aspects like groundwater resources or geothermal energy. But in our opinion, there has not been enough focus on the infill of the Upper Rhine Graben as a sedimentary archive for climate change, landscape change, etc. So for my presentation, I'm going to take you to, along a journey from south to north through the Upper Rhine Graben and look together with you at a few different sites where we have some information on topics like these. I myself am mostly working with drill core records in close collaboration with the Geological State Survey of Baden-Württemberg and in close collaboration with a few colleagues who are looking into things such as fossil contents and into the challenge of dating these deposits. So if we start out in the very south of the Upper Rhine Graben, if you would be driving around the countryside around Freiburg here, what you would encounter are quite a few of these open gravel pits like this one shown on the picture here. And these gravel pits actually show already the stratigraphy, the lithologies, so the facies that we observe in the southern Upper Rhine Graben. Here the infill consists pretty much out of a gigantic alluvial fan of glaciofluvial gravels. And these are exactly these gravels that make it past the Alpine foreland, delivered by meltwater from the Alpine glaciers, and probably deposited quite episodically during close to peak glacial conditions. And a colleague of mine specifically has looked into those in a bit more detail and set out to date these deposits with different luminescence approaches. And what she could show or what she could confirm, this was neither new in its result nor very surprising, is that these deposits close to the top have an age that corresponds roughly to the last glacial maximum. What was really new and really cool about this work is that we could now also date not only sand within our sediments, not only well-sorted sand, but also individual cobbles within our gravels and the sandy matrix of our gravels, which is very valuable because that gives us entirely new possibilities at dating some sediments that have been a challenge for quite some time. But what we could do was we could confirm the LGM age of the top of this alluvial mega fan. And the main question I was asking myself then is, well, what is below? And we could also look at that. we could get our hands on 3 individual drill cores from a little bit further north, just north of the Kaiserstuhl. And these drill cores recovered in depth of up to 40 to 60 meters, mostly the so-called Neuenburg Formation, which is the lithostratigraphic unit that is thought to represent the last 2 glacial cycles, so the last and the penultimate glaciation. And what we have done, we looked into the Neuenburg Formation with a gravel petrographic approach. So looking at the composition of these gravels in terms of different lithologies. And that turned out quite interesting. This is a very busy figure. I would like you to focus on the highlighted column here, which shows the results of end-member modeling of these petrographic compositions. Not trying to go too much into detail, what I would like you to see is that there is some difference between the upper part and the lower part of this Neuenburg Formation. The Neuenburg Formation is everything on here that is not shaded in orange. And we see in the upper part, we have higher contributions of this black end member 1, whereas in the lower part, we observe around 50-50 end member 1 and end member 2. So there is a difference in the gravel petrographic composition in this Neuenburg Formation. And we could also show this with a bit more classical principal component analysis. Here we have the upper Neuenburg Formation in blue, the lower Neuenburg Formation in green. There is a bit of overlap, but there is also quite some difference between those 2 units. And we think, therefore, that they could very well represent this last and penultimate glaciation. So an explanation could be that the Rhine Glacier delivered different shares of its meltwater and of its sediments towards the Danube and towards the Rhine in the last when compared to the penultimate glaciation. Unfortunately, we don't have any ages from these drill cores because the sediment was not really suitable for that. And we have also only looked relatively shallowly into the southern Upper Rhine Graben. So there's definitely some need for follow-up work, looking at longer records and trying to date these records to put some numbers to. But I think these can help really quite a bit with disentangling the stratigraphy of the alpine glaciation. If we move a little further towards the north, towards the central Upper Rhine Graben, I have also one example from there, from close to the city of Offenburg. And here are some cores of this drilling. And as you can see on first glance, it gets much more complex now. So we have close to the base of this drilling at Offenburg, we have again these grayish beige alpine glaciofluvial gravels. But we see now contributions of local lithologies from the nearby graben shoulder, which get intermixed into these gravels. And at around 20-something meters depth and roughly at the time of the penultimate glaciation, we see a very distinct switch in the depositional setting. So we transition from this glaciofluvial braided river system towards these beige fine-grained deposits in the upper part of the stratigraphy here. And these beige fines, these are loess deposits. So that's fine material, silt with a little bit of sand, deflated from the braided river valleys, from the meltwater river valleys in the alpine foreland, and deposited at a lot of places along the margins of the Upper Rhine Graben. And at the site of Offenburg, these loess deposits are from time to time interrupted by intercalations of locally sourced gravels, which look completely different from those from the Rhine system, which are very strikingly red in color and which keep occurring in this profile. And what we also encountered here, and what was quite interesting for us, were two intervals here depicted in gray of grayish silts with plant fragments, which probably represent some kind of stagnant, swampy palustrine settings. And from those, we could actually extract two pollen profiles, two interstadial pollen profiles from the penultimate glaciation and from the early last glaciation. The two stages that are so far not too well represented in the record of the region. So it gets very, very complex and very interesting. I also had the chance to look at a few neighboring drill cores of this borehole at Offenburg. And what I found there was the general sequence is relatively widespread, can be followed for at least a few kilometers here. But at closer look, what got apparent was that the lower part of our section from our drill core, the OWI1, is shifted downward by almost 10 meters relative to all the others further to the south. And an idea to explain this is that we are looking here at the result of neotectonic activity. So we are looking at episodes of differential subsidence of this block that our OWI drilling is located on, that apparently created some topography from time to time. And this topography seems to have been infilled by these reddish, locally derived gravel packages that we see here. So here, the information that we can gain now goes well beyond the alpine glacial signal. Now we have traces of neotectonic activity, we have traces of the flora and fauna and the general environmental setting. So a lot of information to be gained from these sites in the Upper Rhine Graben. But this alpine glacial signal, the one that I set out to find more information on, still exists, even if we keep going further towards the north. So here's a profile from close to the city of Karlsruhe, where we see again major gravel packages of alpine-derived material, notably this one here in the middle, which is, if you look at the luminescence ages, which has a timing of around 450-ish thousand years, which fits perfectly to marine isotope stage 12, which we think is the most extensive glaciation of the Central Alps. And we see the same thing in another borehole a little bit further to the north, again at Kronau, where we have this package again at 450-ish thousand years. So that really indicates that at times, at peak alpine glacial conditions, more or less the entire Upper Rhine Graben was dominated by glaciofluvial gravel deposition derived from the Alps. And what we can also see by those examples here, which are more than 20 kilometers apart, that the general successions look relatively similar, that it seems like there might be packages that can be correlated with each other even without having info on the depositional age. So again, potential for future work for larger scale profile correlation, also with logs of existing boreholes, and of our own boreholes that we looked into in quite a lot of detail. So there is always work to do. Some correlation like this has been done before. I have showed this before. Like I mentioned then, relatively roughly, and mostly from a applied perspective and with a focus on the hydrogeological properties of these deposits, and not so much with the facies architecture thought in mind. So I think that's where we could really gain some information. And with the site of Kronau, we are now located here where the bedrock drops quite abruptly towards the north. So we are approaching the Grande Finale. We are approaching the depot center of the Upper Rhine Graben. And this depot center is referred to as the Heidelberg Basin, or sometimes even the Heidelberg Hole. There we are talking about on the order of 800 meters of unconsolidated Pliocene to Holocene deposits. And that's also something that we've known for quite some while about. There was a pretty famous drilling already during the First World War for the Radium-Sol-Therme at the Heidelberg city, which reached a total length of 1,022 meters. And it was interpreted that the entire succession of this drill core consists of these unconsolidated deposits, and therefore that they are more than 1,000 meters deep at this site. This has been called into question a little bit later on, but we are definitely talking about many hundred meters of these unconsolidated sediments here in the northern Upper Rhine. And especially the Heidelberg Basin was later on in the late 2000s targeted by a larger undertaking, by a scientific drilling campaign, by the State Geological Surveys and the Leibniz Institute for Applied Geophysics, with seismic exploration of the Heidelberg Basin and with 3 new deep drillings by the geological surveys. And the outcome of this scientific drilling project was an unprecedented inventory of the infill of the Heidelberg Basin and a new lithostratigraphic subdivision of the northern Upper Rhine Graben. But we also found that here there is a little bit more that could be done, and we could get our hands on our own drilling from the northern Upper Rhine Graben, specifically from a town called Eppelheim, close to Heidelberg, at the southern margin of the Heidelberg Basin, where we should expect about 400 to 500 meters of unconsolidated deposits. And specifically, we are located here in very close to the site where the Neckar River enters the Upper Rhine Graben. So we are in an area where 2 large catchments and 2 large river systems interact with each other. So very interesting site. And here is the profile of this drilling, of our drilling from Eppelheim, which was 136 meters long and reaches back well more than 500,000 years into the past. And what we can see is in the lower part of this drilling, below 90 meters depth, mainly fluvial gravels, fluvial sands, some intercalated colluvial diamonds, which are overlain by roughly between 90 and 55 meters, but by a large-scale fining upward cycle, fining into silt and clay. And in the upper part, above 55 meters depth, we have again encountered these fluvial and colluvial deposits similar to those below. And we could also distinguish quite nicely deposits from the Neckar system, which apparently is dominant here. These are all the deposits that are shown in the reddish colors, and sediments from the Rhine River system, which are shown here in these bluish and greenish colors. The two fascias can be very nicely separated from each other, both in the gravel fascias by the composition of the individual lithologies, and also in the sand fascias. As you see here on these two images, these two sands look very distinct from each other. And it has been suggested before that the pattern of deposition in this area of Rhine or Neckar dominated deposition is mostly tectonically controlled. So one explanation could be that during times of little subsidence of the Heidelberg Basin, the Neckar is accumulating a alluvial fan that progradates into the Upper Rhine Graben and that deflects and pushes the Rhine away towards the west. Whereas during times of strong subsidence of the Heidelberg Basin, the Rhine River gets drawn towards the eastern margin of the Upper Rhine Graben. And also that, at first glance, seems to fit here quite well, because we see increased contributions from the Rhine surrounding this fine grade interval at 55 to 65 meters. And these finds could suggest very well that we are looking at a high ratio of accommodation space to sediment supply. So this appears to fit at first glance really well. We have looked at these finds in quite some detail because they are really, really beautiful. We are speaking mostly about clayey silt. We see in detail three fining upward cycles. We see quite a few gastropod shells already on the core surfaces. Towards the top, we see increasing amounts of organic carbon. We encountered entire tree roots going through our drill cores. Very, very beautiful sediments. And also here we could extract a pollen profile that tells us more about the environmental setting. What we see here are at the base probably quite cold conditions. So large portions of grasses like Poaceae, Cyperaceae, and towards the upper part of this succession, increasing amounts of trees, increasing amounts of worm-loving trees that show that the flora got more diverse and more fitting with a temperate setting. In blue colors, we also could find some remnants of aquatic plants. And I would note especially the Azzolla species, which shows us that in the uppermost meter of these deposits during the time of deposition, the climate was at least as warm as it is today. So very high record of the environmental evolution. I have mentioned some gastropod shells. We also took a good look at those in detail. It had been suggested before that these finds could belong to a large-scale lake forming in the entire Heidelberg Basin during that time. But surprisingly, the majority of gastropod shells that we encountered are actually terrestrial species. However, there are distinct intervals, which are here shown by the blue colors, where we have prevailing aquatic species. So at least here at the margin, at the site of Eppelheim, we are not talking about a proper lacustrine setting, but rather about some kind of palustrine swampland, which gives us way more information about what the environment looked like. So I have tried to visualize this a little bit here, how I imagine it might have looked like in the area. So we see we are in some sort of Palestrine wetland setting during the timing of deposition. And we observe a gradual climatic amelioration, probably from a late glacial towards a almost full interglacial setting. So that all fits together again very, very nice. One thing that is still a little bit unclear is the timing of this interval. If we look again at the overall profile, this suggests that these Palestrine deposits at 55 to 65 meters here could be around 400,000 years old, which would suggest that they represent the Holsteinian interglacial. And it seems like they are truncated by an unconformity at the top. But what we encountered in terms of pollen and also what we could see from aminostratigraphy, so from the decay rates of various amino acids within our snail shells or parts of our snail shells, suggests that we are looking at a older time period of at least a interglacial prior to the Holsteinian. So that is still a little bit unclear. And we are actually not the first ones to have a bit of a headache here in this area, because previous studies report in exactly these fine-grained deposits at least 3 different interglacial pollen assemblages and at least 2 different gastropod assemblages as well, which would indicate that there's a lot of time somewhere hidden or being lost in our record there, which is a bit intriguing if we are talking about a time where we presume high subsidence rates. So I have to say I don't have a solution for this yet. Maybe we can come up with something in the discussion in a few minutes. I have an idea though about what to do. I'm planning to have a closer look, or I'm already starting to have a closer look at the same interval in the Heidelberg Uni Nord drill core, which is one of this scientific drilling project, where the entire Ludwigshafen formation, so this entire interval, more than 70 meters of sediments, is entirely fines dominated, and where we might have a better chance to find a complete succession of this time interval here. We will see. I am carefully optimistic of what's going to come up from here. And with this, I'm going to sum up. So I hope I could show you that there is really value within the Quaternary sediment record of the Upper Rhine Graben. We are looking at a huge sediment sink with potential for more or less, with a question mark, continuous deposition over timescales of at least 500,000 years, probably way much more. We observe climatic as well as tectonic controls on the deposition. We found already quite a lot of information on the alpine glaciation history and the traces it left in the wider surrounding. We found already quite a lot of traces of quaternary environmental change, which we can encounter in these deposits. So there are already some very important puzzle pieces, and I'm now at the beginning of fitting them together. So there's still some challenges left, but we're going to approach those step by step. And with this, I'd like to thank you very much for your attention, for the invitation, and I'm looking forward to your thoughts.